Hi everyone, this is Kalia from Marcus Evans. Thank you so much for joining us today on this webinar on avoiding disaster, grounding and bonding for the safe transfer of hazardous materials. This is brought to you in partnership with AEMC Instruments. Before we begin, I'd like to cover just a few housekeeping items. As you can see at the bottom of your screen are multiple application widgets. They're resizable and movable, so please move them around to get the most out of your desktop space. We'd also like to encourage you to submit any questions that you might have by using the Q&A widget, and we will try to answer as many questions as possible during the broadcast. However, if a full answer is needed or we perhaps run out of time, we'll make sure to send you an email afterwards. Also like to draw your attention to the resource list that will contain today's slide deck and interesting articles, and please bookmark any links that you might find useful. To answer any common technical issues, I advise to use the help widget. And finally, a reminder to look out for an email within the next 2 hours with links to view today's session. At this point, I'd like to introduce you to our moderator and our host. We have with us Mr. Gregg Wong, who is the Technical Product Trainer at AEMC Instruments. Very happy to have you on today, Greg, and I'm going to hand things over to you now.
Thanks, Kyle. Today on the webinar with me, I also have Ronnie Roberts, who is the president of RENSCO. Ronnie, thanks for joining us.
Thank you so much. Yeah,
also,
I'm Ronnie Roberts. I've been in the response business for 30 plus years for hazardous materials response. 25 years of those were spent on the Oklahoma City Hazmat team. About 23 years of that, I was actually on the Hazmat team, responding to numerous rollovers, flammable liquids, different types of product releases over the years. After that, I got into, retired and got into oil and gas, where I served as safety director, emergency response director, and for various companies such as Devon Energy, Continental Resources, Lloyd's Register, and then recently Antero Resources, Antero Midstream out of West Virginia, Denver. Thank you for having us today, and I look forward to talking to responding to hazardous materials incidents.
Great, Ronnie. We look forward to hearing your perspective on this important subject. Also on the phone with us, or webinar with us today, is Glen Rudner. Glen is the consultant and instructor at GDR Consulting. Glen, tell us a little bit about your experience.
Hi, Greg. Well, thank you very much for having me as well. I have 47 years in the emergency response field, starting as a volunteer firefighter, running into the world of the paid fire service, became a hazardous materials response officer for the Commonwealth of Virginia, and retired from there. I also went to work for the Security Emergency Response Training Center in Pueblo, Colorado, doing training for first response community, where I also installed several of the newer programs and as well as changed the practices and came to within the NFPA standard for grounding and bonding. In addition to that, I worked for Norfolk Southern Railway, and then after a 47-year career, decided it was time to get out and start doing what I love to do, which was training first responders. Just like Ronnie, I've been on multiple hazardous materials responses, trained derailments, rollovers, where transfers had to be done, and had to train first responders on how to respond safely, effectively, and efficiently using grounding and bonding as one of the key pieces, especially when transferring flammable liquids.
Great, thanks, Ronnie. And I would be remiss without mentioning that you have been incredibly instrumental in helping AEMC Instruments get the word out about our ground and bond kit for first responders. So we thank you for that. Again, my name is Gregg Wong, I'm our technical product trainer, and I do want to mention the AEMC Instruments static ground and bond test kit. We manufacture and sell this innovative kit for hazmat first responders. This kit includes everything you need to safely deploy and test a temporary bonded equipotential plane of ground to reduce the risk associated with static. So before we begin our discussion, let's start with a poll question. before this webinar, how confident are you in your understanding of static electricity and its impact on hazardous cleanup, hazmat cleanup? This is for our audience, so please go ahead and select either very confident, somewhat confident, neutral, not very confident, or not confident at all. We'll reveal these answers in a follow-up email. So for our panelists, the first question we're going to tackle today, and this will go to Ronnie. As a first responder on an emergency, such as a spill or a leak, in your experience, Ronnie, how can we safely determine the hazard zone and what actions we should take when we first arrive? I think we lost Ronnie as well.
With that, thanks, Greg. Appreciate it. Without knowing levels of training, I think we ought to go with the basics of responding to hazardous materials incidents. So we'll talk a little bit about actually, even from a fire department perspective, understanding the weather before you even leave. I think for years we could look at a flag outside of our fire station. We almost knew what the wind direction was and the speed of the wind just from that flag going to an incident. So weather plays a big role before you even get to the scene, understanding your wind directions and things of that nature. Scene management is a big part of responders. In particular, people, general public loves to get in the middle of our spills, trying to help. Of course, if there's rescue situations, things of that nature, always remember when you're arriving on a scene, uphill, upwind, upstream, are going to be the ways that you want to approach these areas before you start setting up your zones. You also have things such as positioning of vehicles. Love the police department. Sorry if there's any police officers on here, but had guys pull in within 10 feet. Typically, traditionally they're 1,000 feet away is where they should be if you go by an ERG, sometimes up to half a mile, depending on what the actual product is doing. So positioning the vehicles, making sure general public's out of the way. But setting up hazard control zones it can be also tricky as well. Topography plays a big role in how you set up your zones. You have a hot, warm, and cold, or our traditional zones in the fire service. A hot zone being a very controlled area. That area needs to be determined by what's happening with the product, what's happening with the particular rollover scenario, and actually there are drains and things like that in the area, or creeks or rivers that you want to stay out of. So all that plays in a big factor in the zones. But our hot zone is very controlled. You don't go into the hot zone without proper PPE, proper training, proper monitoring devices and things of that nature. Then, of course, the traditional zone for the warm zone is where we do decontamination. So if you have general public that's actually involved in the incident or have been walking through the product, or you have a driver of the vehicle that needs to be rescued and decontaminated, that would happen in the warm zone. And of course, setting up a hazard zone for the cold zone is where we want to keep our responders in a safe location. A lot of people have different opinions about how to set up these particular zones. Some people use time-weighted average for whatever the product is inside of the tanker. Most departments will probably get within 500 to 1,000 feet and start monitoring with the 4-gas monitoring sensors. So a lot of those different things will be part of setting up the hazard zones once you arrive on site. Now, of course, making sure you have an emergency escape route, knowing how to evacuate if something happens or goes south on you, such as a fire, explosion, or a large release. You need to know how to evacuate the area, such as a long blast from a fire truck or a 3-horn blast is typically what a lot of people would use. But that's a very important piece of understanding how you can safely work out of these zones and when you need to get out of the location. Some of the other key things is just immediately up front identifying what the product is. So looking at placards, looking at labels, trying to get your hands on the manifest, the shipping tickets. All these things are going to play a big role in how you set up your zones, in particular if it's a flammable environment, which typically would extend your zones in the area. You also have things such as low-lying areas, creeks, every different drains, things that you need to probably dam up rather quickly to help control those zones. Those would be extended parts of the hot zone, most likely. And then, of course, decontamination would be required after you do that. The other thing is just if you don't know what you're looking at as a product, there are ways to identify what you're dealing with, such as placards, labels. Industries helped us a little bit by making oval-shaped aluminum tanks, which would normally carry our flammable products. So those types of things are things that you probably want to train on, get used to before you respond on these types of emergencies, and of course setting up the zones. And if you have questions, you're not familiar with a particular manifest or shipping document, calling Tim Trek, asking for assistance, technical advice is always a great way to go. But one reminder, just I know I've responded to numerous flammable products. You always want to make sure you can try to verify through monitoring what the chemical actually is. I've made several calls where I was handed the wrong safety data sheet. Ended up getting exposed to something I didn't know it was, and it's actually turned blue. So identifying the product is really important, making sure you have accurate information, setting the zones up appropriately, marking those zones, keeping people out of those locations are going to be very critical for an efficient response. So as far as the safely determining hazard zones, again, hot, warm, and cold. The hot zone is the control zone, the warm is the decontamination, and then there's the cold zones where you're going to keep your additional equipment and additional personnel. So that's what I got on panel question 1. Thank you so much.
Great, thanks, Ronnie. It sounds like we want to establish ahead of time that we know what we're doing. We've trained properly. We've received the correct education, and if we haven't, we're not going to approach the scene. We're going to stay in that zone. In the electrical industry, we have a saying that's stay safe, it's stay clear. So it sounds like that would apply really here very well too. We want to try to keep everyone at a safe distance and be prepared for these different scenarios as we arrive to the scene. So let's jump into our next question for the audience. Survey question: how often does your organization conduct hazmat incident responses? Daily, weekly, monthly, quarterly, annually, rarely, or never? And again, we will follow up in an email to reveal the answers to these questions in a later email. So next panel question for Glen. Glen, it sounds like Ronnie's established where we need to be at the site and where we're going to begin our response. So as we progress on the site, we're going to run into some static electricity concerns. What are the associated risks with static electricity, and what areas of static generation should we really be most concerned about?
Well, Greg, in starting to think about it, what are the risks associated with it, of course, is the fact that a static discharge on an incident scene, be it a recovery of product, a cleanup, or a emergency response, is going to be an issue. We have to be able to control that static as quickly and as safely as possible. The areas of generation that we have to be concerned about are very simple, and that is anything that has movement can produce a static discharge. And if it does so without control, it can cause an issue with regard to response. Some of the things that I've learned over the years is that you can take a look at products, everything from the hazard classes as described by the Department of Transportation. If we look at all 9 hazard classes and then determine from those hazard classes which are going to be my primary concerns for static discharge, we will find that all but one is a major issue for us. When we look at flammable gases, well, let's start in the beginning. Hazard class 1 are explosives, and we know that any introduction of a spark or type of energy would cause a detonation. We know that in hazard class 2, we have 3 different hazard class or subclasses, One being the flammable gases. That's a major issue with a static discharge. The next movement would be with the non-flammable gases, which is 2.2. And even though they're listed as non-flammable, because of the definitions by the Department of Transportation, there are products that are actually flammable, and a discharge can cause a fire and or explosion. Products like anhydrous ammonia. Hazard Class 3 uses carriers that may be flammable. In Class 3, the bigger issue is the fact that we're dealing with both flammable and combustible liquids. And if we look at the amount of flammable and combustible liquids that are moved on our highways, by rail, by marine, and by pipeline, the chance of an incident is even greater than ever before. Hazard Class 4 are flammable solids, combustible solids, products that can cause or that are dangerous when wet. They're all listed with a flammable placard or have a flame on top of each of them. The Hazard Class 5, which are oxidizers and organic peroxides, require just a small amount of energy to cause them to discharge. And of course, with a static issue there, we really got to concern ourselves. Hazard Class 6, the same issues, because of the fact that many of our Hazard Class 6s are both toxic, many of them do have flammable components. Hazard Class 7 are the radioactives, and in the majority of the cases, we really don't have a whole lot to move with those and rely on specialists to do so. So the chance of static discharge is very limited. Hazard Class 8 is another one of those that has a hidden danger. When we look at acids and bases, the movement of them through incompatible piping or hoses or in the wrong type of container can cause static discharge, as in this case of Hazard Class 9. So our areas of concern when it comes to static generation is the movement of liquids, solids, and gases in 8 of the 9 hazard classes. That's where I'm worried about it, especially on an emergency response. But during cleanup and environmental remediation, those same safety hazards need to be observed.
Yeah, Ronnie, I think it's interesting to hear you discuss the different hazard classes. Coming at this from a somewhat uneducated perspective, as somebody that comes really purely from the electrical field, I hadn't had very much familiarity with these concepts and different chemicals and these different hazard classes that they fit in. And so it just points out the reason that first responders have to be just cross-trained on so very much, and how important it is to really understand these concepts before you're responding to a site. So this training is just integral to the safe and effective cleanup and response.
And during Ronnie's discussion earlier of the hazards, recognizing what products you're dealing with is going to take you to the next step. If you recognize your products, you identify what you're dealing with, you produce a hazard zone for safety, then the responder can move to the next step, and so can in working with their contractors to do the cleanup and remediation.
Gotcha. Thanks so much. Any comment on the environment too? Because when we think about static, we think about obviously the release, the potential release of the product that's being transferred, but I also think of the environment as well too as being a potential risk.
Very, very much so, and that's why once again during the period of remediation, the environmental contractors have to be very aware that the products that they may be producing will also still have the issues with regard to static generation, the issue of moving products like gasoline, which is a conductive product, which can cause us major issues. Again, we take a look at the possibility of the incidents based on the amount of transportation of the products and movement of the products. We know that the majority of products moved by, again, the methodologies of transport of rail, highway, and pipeline, as well as even intermodal classes, we're seeing more and more flammable liquids, products like ethanol or denatured ethanol fuel, gasoline, diesel, and so on. So again, we do have to be concerned as those contractors start putting in and using things like vacuums. They're cleaning up, and of course that movement at high speeds can cause that issue.
Great. Thanks, Glenn. So let's move on to the next question for our audience. And I think this is the most critical question we're going to ask you today. In your opinion, what is the most critical factor for a successful hazmat incident response involving static grounding? Is it proper training, reliable equipment, strict compliance, effective communication, and other? Please specify. And again, we'll reveal the answers to these questions in a follow-up email. But just very, very briefly, Glenn, what is your take here? What would you say is the most important thing, just in a couple words?
I think the best way to look at it is combining most of these items together by being able to properly train with good equipment and practice it on a regular basis, following a step-by-step standard operating procedure. This is one of those that is step-by-step.
Yep. Yeah, so if we think back to the first question with Ronnie's response, we want that training and we want to know how to communicate, and then getting into more of the static conversation with Glenn, we want to make sure that we have a reliable system before we arrive. That could be something similar to the kit that we're discussing today. And we want to make sure that we have all the training and ensure that we're aware of what it is that we're actually transferring, so that we can be prepared for the scenario and for the transfer to go without any incident. So the next panel question will be handled by Glenn, and that question is going to be: which components must be correctly grounded and bonded, then tested? And that testing piece is really important to this question, prior to the transfer of flammable materials, to ensure that no hazardous material transfer ends in tragedy, and this move is successful and we all go home. Glenn.
Well, this is pretty simple to start with. We need to make sure that prior to doing any grounding and bonding of the equipment, and that is the damaged container, the recovery container, any type of pumps and hoses that are put in, we need to make sure that whatever we start with, we have to check to assure that the ground will accept the charge. That is the first and foremost of anything that we do. We start off by doing ground resistant testing. Once we have done our ground resistance testing and meet the requirements under the standard and or regs, or whatever the authority having jurisdiction has set as their numbers. According to the NFPA, under NFPA 77, it states that they must have a minimum of less than 1,000 ohm. Now, for many years, that number was at 25. That, since the additions of 77 over the past 15 years have come out, they've changed it based on science and computations that 1,000 ohm is a good number. But we must make sure that each of our ground systems that we set up for any transfer has to have that same number. In addition, once you start hooking up your equipment, and a checklist is very simple to follow, in that you're first going to go ahead and attach a cable to your damaged container and test to make sure there's no resistance between the clamp and the container. Then you attach that cable to your grounding rod that has been tested. Again, making sure that you're less than 1,000 ohm on the connection and that you have a clear path for any static to discharge at that rod. You do the same thing with your recovery container, the same thing with your pumping system. Each of those things will be correctly grounded first, and then, and only then, can you decide on a bond. And the bond, again, you want to take that bonding cable and the clamp and take any chance of a discharge away from the damaged container. So you'll hook your cable to an appropriate place on the damaged container, and you take that over to your recovery. Once all of these are successfully below 1,000 ohm as you've done your connections, then and only then you should then give it an opportunity to relax the charge, and that's going to vary based on, again, science and the materials involved. And once you've allowed it to do so, then and only then should you start your transfer that will become a successful and quickly done, safely done incident ending.
Right. So I want to catch a few points that you made there. First off, the conversation behind what value we should have when we go to perform our ground resistance test. And this could be on a single driven rod. It could be on multiple rods that are connected together. This is a hotly contested issue that we run into seemingly on a day-to-day basis, it seems like, with different departments and organizations responding to these types of sites. And I want to highlight very quickly that 25 ohms comes from the NEC, and that's in reference to a permanently installed electrical ground rod, ground electrode, right? Typically a rod. And that is not referring to a static system. Now, obviously, the lower resistance, the better. And that tends to be the first place that I start with some training on this subject, is that we're looking at a size of a pipe, essentially, to equate it to something that's a little bit more understandable. The bigger that pipe is, the more voltage or the more static I can get through that pipe. And that's really simplifying it. So when we bring out the mega ohm or the 1,000 ohm requirement that we find in other documents, that's really what we're referring to there. We're not installing an electrical ground. We're installing a static dissipation ground. So any more comments on that, Ronnie? I'm sorry, Glenn.
Yeah.
I keep getting you guys confused. I apologize. Glenn, any more comments on that?
Again, it's going to be based on the size of the transfer, how fast it's going. You know, one of the things that we've always said is the way to relax and make sure that you're not generating too much static charge is to keep the transfer at a constant slow rate. This way you don't. And again, it's based on the hoses, it's based on the length of the hoses and the time involved.
Yep, got it. All right, so let's jump over to our fourth panel question. This one's going to be for Glenn as well too, and really kind of delving down into that subject of static grounding and bonding. What are the latest techniques and processes and systems you have implemented and discussed in your trainings to mitigate the risk of dealing with hazardous material transfers? And I'd love to hear some examples that you may have from either your time in the field as an active firefighter or also in your training experience as well too. Glenn, I believe you're muted.
Sorry about that. I have noticed that over the years, there is a lack of training, understanding, and use of the process of grounding and bonding, not just in the first responder community, because reality is when it comes to an incident, once the life safety portion, the incident stabilization has been taken care of, grounding and bonding becomes secondary to the emergency responder. Okay, they can go ahead and do a ground in order to safe the damaged container. And then they only do the balance of grounding the recovery container, the pumps and everything else, if the contractor that arrives on scene to do the cleanup, because fire departments typically do not do cleanup. They are there for the emergency response. There was an incident that occurred in a jurisdiction that I worked where a toluene tank truck heading down the highway had a slow rollover and ended up on the side of the road, on its side. It was going to have to be transferred. We brought all the equipment in from the fire department. They were there and they initially grounded the container. They followed the process in which they were trained and they did it right on target. our contractor arrived, and his interpretation of grounding that tank for recovery was to take a 12-inch screwdriver and a set of battery cables as his grounding device with no bonding. And I had to explain the process to him. Once I explained the process to him, we had the fire department go ahead and set up both the grounding field on the damaged container, it was already set, but on the recovery container, as well as the bonding of the recovery container to the damaged container, and then the pumping system that they brought in and their hoses. We had to show them how to do that. We then started working with some of our contractors in the region to assure that they had that ability. Now, one of the things that has made a difference in the industry today is the fact that there are several different ground-resistant systems out there, but having everything in one spot is real important. Explaining to the response community why you have multiple rods, why you have multiple grounding systems. There are systems that are available today that are single point systems. However, there is a concern that you may have somebody on your team or may have that public that you described earlier that may disrupt your grounding field. So there's a lot of examples that we can use of having issues on an incident scene. However, again, you look at the product you're dealing with, how long that you will have that area. That truck that rolled over was on the side of the major interstate highway. You can only keep that just closed just so long during rush hour before people get agitated, and so does the law enforcement agency.
Yeah, and I'm just watching the questions come in from the audience here, and it's obviously they're very engaged because they're asking questions that we're already kind of giving some answers to. So I can see that whoever's attending right now actually has some experience in this. We'll get to those questions later on. You know, you mentioned the importance of building multiple grounding systems, and that is to establish when I say a system, a driven rod or an electrode into the earth. We have those what if scenarios, right? So redundancy is key here. If I drive just a single rod and connect everything to it, and especially if it's not tested, I have no idea, you know, like the example of your screwdriver, I have no idea what the resistance to earth there is. And now in my experience, a mega ohm of resistance, if that's your standard, is pretty easy to accomplish in the majority of soils that we deal with. However, we can be in parts of the world, especially in rocky environments, the Pacific Northwest, any of the coast, South Carolina especially, where if we drive a single rod, we still may have 1,000 ohms or greater easily sometimes. So it's really dependent on where you're located, on what you're going to get on that rod. And that's why that testing perspective is so very important. I know something I've heard you mention in your training and when you're giving talks is know what the soil is around your respective response areas, right? And I think that's critical to preparing for a situation like this. So any other feedback?
First responders can prepare for that. If you are a regional response team, then speak with your state Department of Environmental Quality, your local ag extension services, local farmers, but know what the soils are that you're going to deal with. Also recognize that there are other issues that come to play. Again, allowing me to use another example, we had a gasoline cargo tank fully loaded at a shop that the operator of the shop made an error and dropped the front end of the cargo tank, dumping about 3,200 gallons of gasoline on the ground. They were going to have to offload the balance of it, and the fire department hazmat team that responded wanted to ground that tanker before the contractor showed up. Well, what they did is they became very narrow in their scope of where they were looking, and they found a parking lot next to where the incident occurred. They measured out the appropriate distance and found that they were going to be right in the middle of the asphalt. They ended up having to drill through the asphalt, and then start to try to drive a rod. The problem they ran into is you had 6 to 8 inches up to 10 inches of asphalt, or depending on where you are, concrete. Then you have the sub bases that are in there, everything from rock to crush and run to disturbed soils. They drove a 6-foot rod in and could not get below 5,000 ohm resistance. They then said, well, we're going to have to drive more rods, which means we're going to have to dig up more concrete or blacktop. And what they failed to look was behind the incident, there was an open grass field. The first rod they drove into the fresh, untouched soil got them down below 100 ohm on one rod. So therefore, knowing your jurisdiction, knowing where you're responding, knowing those answers will help you in determining where you ground.
Right. And showing up prepared with a kit similar to what AEMC is manufacturing that has everything that you'll need to not only drive that rod or multiple rods for your incident response, but also perform testing and continue to perform testing while you're on site. So your incident policy will have a specific timeline in which we may be performing testing on an ongoing basis, depending on how long our transfer is taking, right?
Without a doubt, without a doubt.
Got it. Great. Let's get back over to Ronnie with this next question. So Ronnie, in what ways can we provide a safer working environment for those handling these products? You know, we discussed at first with you the zones at which we work at, and we want to be conscientious of the first responders that are on site, maybe as the general public, or as you mentioned, the police who may respond, get a little bit too close. But what other ways can we help secure the site to ensure that we have a safe working environment for those involved?
Well, thanks, Greg. I think a lot of the things for a safer work environment really does have to do with what we've been talking about, a lot of training, proper equipment use, that don't generate static electricity or have a flammable environment where you're using the wrong tools. So, but, mostly industry's helped us quite a bit in the sense of understanding what we're dealing with on handling typical rollovers would be in the type of containers that we look at. So when we pull up to a location with a little bit of training, you can understand what products are typically put in these various containers, such as a MC 306 or 307, 406. All these numbers do mean something. So, for example, an MC 312 is corrosive products. So by just understanding the type of container that you're dealing with when you pull up to the location, will help you tremendously on how you need to properly dress. Do you need to put foam on the location or some type of vapor mitigation technique? So with industry, they have things such as flame arresters on these tankers. They have pressure vacuum valves, vapor recovery units. All these things industry is doing to make it safer environment for firefighters, first responders to respond. So, flammable vapors is what I focus on a little bit. We typically utilize foam products, as I mentioned earlier, and foam runoff is a big problem for a lot of our health departments. They don't want foam in their stormwater runoff type locations. So, you need to be careful as far as containing those type of products. You also have to look at the flammable vapors that you're responding to as well. So just understanding the basics of a monitor. I've had situations where I've been in charge of a hazmat team, and one of my guys goes out and he monitors. He didn't quite understand what his monitoring was reading, so he decided to evacuate half a neighborhood. So understanding what you're reading with your monitors is a really critical piece too. So we typically have what we call lower explosive limits that we need to monitor for. So as long as you're in the environment where you can actually process, grounding, bonding, working for the transfer, and that your flammable environments are low enough that you can perform these safely, it's going to be very, very critical for that first responder. The other things, if you had things like shut-off valves, most of the tankers have a shut-off valve on the driver's side front. If there's a way to protect somebody, go in and start shutting these valves down to prevent further leakage, that could be a really critical thing. Hatch covers being covered, the piping that's being damaged that could be secured fairly quickly. So really just shutting off our sources, right, of how this product is leaking from that container is a pretty critical piece. And the other thing to keep in mind, a lot of people overlook disconnecting the battery and the transport vessel. That could be a critical mistake as well. And then of course the tank and the cab itself, is it chocked? Is it going to have any kind of movement when you're trying to process through with your transfer? A lot of times, depending on the trailer support legs and stuff, sometimes those collapse or they could have been damaged in the rollover. So you've got to consider, using some type of airbags or some type of products to help stabilize that particular scenario. And we always, I call it Murphy's Law, what's going to happen next probably will happen. So when you start thinking about where is this product going to go and how is it going to affect neighborhoods or businesses in the local area, and then just really reassuring that you have those drains and those streams and things covered so you're not damaging the environment as well. So diking and direct flowing containment areas is really, really pretty critical to the whole process. And then bonding and grounding, of course, is we've talked a lot about here, is a very critical process as well as part of that safer work environment. But as we mentioned earlier, the training on labels and placards, and I will forewarn you, if you see a UN 1993, that's United Nations 1993 on a placard, and that typically will show up as flammable or combustible, just because I worked in the hazardous waste industry for a long time, we always labeled our flammable products as such. So when you see 1993, it was always a number I thought as a hazmat responder, I really don't know for sure what I'm dealing with, because that is considered what we call flammable liquid NOS, not otherwise stated, or combustible liquid. So those products pose a little bit of a problem because you don't quite you don't understand the characteristics of that, right? So there's many things that you can do to provide a safer work environment, and in particular, understanding the product that you're dealing with, what type of fire suppression techniques you want to use to handle these products. May not be foam, maybe something like microblaze is a product we used quite frequently back in the day to reduce vapors. Understanding when your ignition sources, as I mentioned, disconnecting the battery on the tanker, the tank itself, the cab. So all these things become very important when you talk about dealing with the environment. And one other thing I'll mention that people don't understand, some people don't understand vapor density. So understanding what's going on with your product, where are these vapors going? Are they heavier than air? Are they lighter than air? We refer that to vapor density. So greater than 1 means it's going to stay low to the ground. And most people, like even hazmat guys, you ask them, where's gasoline going to go? It's going to rise straight up. And that's not necessarily true. It's going to stay low to the ground. It's going to look for ignition sources. So identifying your ignition is another really critical piece for that response. So, yeah.
Well, and so you're go ahead. Sorry.
No, those are really critical pieces for a safe work environment for first responders.
Yes, and again, I just have such an appreciation for this industry and the people inside it, because you really just have to be a real jack of all trades to respond to an incident like this. And I know that the individuals on this call probably do so very much in their communities to keep their citizens and their friends safe. So it's just fascinating to hear, you have to disconnect the battery, and then you also have to know about vapor, and then you also have to consider the environment and the diking to keep everyone safe, not only in the short term, but in the long term too, because we don't want to be putting any type of hazardous chemicals into the environment, of course. So really, I mean, just again, coming from an outsider's perspective, I learned so much in these trainings and these events. So and have such an appreciation for the people that do this type of work. So you're on this next question too, Ronnie, and I think you've already answered it. So let's just briefly touch on it very quickly because we are getting closer to our hour mark here. But you mentioned the diking. When we talk about the dangers associated with a hazardous spill, are there other things that we should be looking at outside of making sure that we're containing the site and looking at the vapor suppression? And then in the first step, we're keeping everybody away from the site, of course, to keep them safe. But are there any other nuances you'd like to add to your response, Ronnie?
Yeah, I think really just mostly around personal protection, right? PPE equipment is very, very critical. Most first responders have bunker gear. So responding to like a corrosive liquid is not a good idea, right? With bunker gear, it's not designed for that. So, as Glenn mentioned earlier, and I think I've mentioned a couple of times, you have to identify your product right up front. That is the most critical piece to dealing with any type of safe response for protecting our personnel, but also the proper PPE. So if you go into an flammable environment that could have corrosivity as well, you're going to have to protect for both. So having FR resistant clothing underneath a chemical barrier type suit or encapsulated suit, potentially level A, that is going to be very important to know. So, I think this understanding the dangers of what you're dealing with and the different classes that Glenn had mentioned earlier are going to react totally different once they release from that container, whether it's producing an acid cloud or a flammable vapor environment. So, those are the key things that you've got to learn to identify early on, and you've got to be able to protect yourself when you go into those environments. And I think firefighters find themselves, I got bunker gear, I'm good. And that's not necessarily always the case for oxidizers or corrosives and things of that nature. So I like the old adage, and Glenn could probably appreciate this, when the firefighter told me that if I can see that incident around my thumb, I'm too close. That's where I want most of our guys that don't understand hazmat, right? So, but that to me is again, the more critical piece. It's just the proper training and proper protection of our staff when we're responding on these types of incidents. So,
got it. I will remember this. I will stay back here and let y'all take the lead on that. So thanks, Ronnie, for your response there. Obviously, we want to keep ourselves safe, keep the people safe around us, and last, keep the environment safe. So those are great perspectives. Glenn,
there's something, Greg, there's something, and Ronnie, which both Ronnie already knows, but one of the things from the responders community, and especially for all, and that includes the law enforcement officers, fire, EMS, hazmat, even today, many public works folks that respond to these incidents, they all carry the emergency response guidebook. And Ronnie referred to it a little bit earlier, and that's the orange book that's published by the Department of Transportation, Pipeline and Hazardous Materials Safety Administration. One of the key parts of that book, though, is the instructions page on page 2 when you open it up. And right across the top, it says, resist rushing in, stay upwind, uphill, upstream. Those pieces of information are so important to anybody that comes to these before we start doing everything that we do. Know who you're battling before you start the battle.
Right. Yes, and we've got to keep considering those things as well too. I'm sure the wind could change on very quickly in that situation. So we want to make sure that someone is being aware and paying attention to environmental changes, right?
Yes, without a doubt.
Got it. So Glenn, this last question is for you, and we've already done such a good job of maybe covering some of these subjects that will be in this question. So we'll just give it a quick look at it and see if we can build on it. But if you want to share some perspectives on grounding and bonding recommendations, both standards and regulatory requirements, and more importantly, how can we improve emergency operations by establishing effective incident response techniques? We talked about training. We've talked about making sure that we're prepared with something like similar with the AEMC kit, vapor suppression, all that good stuff. What else can we add to these, add a little bit of nuance to it?
Well, I think the first part of this question is the most important to anybody, and that is the fact that under the regulatory side, under OSHA 1910-106, it tells us that we have to control static electricity during the transfer and or movement of flammable combustible liquids. It's very clear. So we've got to make sure. And then on the other side, when we talk about standards, which are consensus, what's even more important about that is they also fall on the tort side of law, i.e. you can be sued, which no industry or business wants to deal with. But they clearly state under the NFPA standards, where you have NFPA 470, which is the standard for emergency responders, and I'll leave it just as a generic standard, but it's the training competencies for all first responders. And under the NFPA 470, it states under several of the modules or chapters that are listed in there that first responders at the hazardous materials technician level must understand and be able to do grounding and bonding following the standard, which then refers them to another NFPA standard, NFPA 77. NFPA 30 talks about flammable liquids and grounding and bonding. The NEC 250 discusses grounding and bonding. So you have several regulatory standards along with several consensus standards that tell us we have to do it. It's a good business practice. It keeps us safe during those transfers. And the best way to improve our operations is pretty simple, and that is to train to the standard, train to the regulatory piece, and make sure that we have people that may not have to do it, but they have to be able to observe and watch. Again, I can go back to the contractor that showed up with a 12-inch screwdriver and a pair of battery cables. And basically, you have to stop them from the bad practice in order to maintain the safety of the personnel that are there, the safety to the community, and the safety to the environment. Again, from a emergency operations side, for an incident management perspective, the fact that we have to understand unified command, incident command, and all of that when it comes to an incident. The guy at the head of the food chain, the guy that is the incident commander, becomes responsible for everything that everybody does underneath him. Yep. So why not make sure that we have that in our toolbox? Make sure we do it correctly, safely, effectively, and efficiently.
Great. Yeah, I've always appreciated your perspectives on these things, Glenn, and I think you're probably one of the best advocates, not only for AEMC's static and grounding and bonding kit, but for ensuring that everyone is safely trained and has the experience to be able to work one of these sites. Your insights are integral for understanding why it is that this training and this response is critical for everyone on the site to understand and sit through. So let's grab a couple questions from the audience here. We've got about 7 minutes left. And we'll see what Glenn and Ronnie think of some of our audience questions, which we've had several here. So the first question we get, it's kind of a combination of a few questions that were asked, is, are there soils where it just works? And I assume like another question asked, why does the resistance change when ground rods are driven in different locations? So these questions are similar in nature. So generally speaking, why is it that we get a specific resistance value in one part of the world and then see a completely different resistance value in another? And I'd be happy to help on this question too, because this is more my area. But Glenn, can you share some perspective on this?
Well, when you have sandy, loamy soil, you're going to have a hard time, rocky soil, things like that, because you don't have the compaction, the ability of the earth to absorb that charge. So therefore, you run into problems based on that. There is excellent direction and gives you basic minimums that you might find in several instruction books. One of those being what I like and I refer everybody to is the AEMC's book on ground resistance. How do I do it? And it has a chart in there that breaks down several different types of soils and the types of resistivity that you're going to run into. So I use that as a baseline. But more importantly, let's go to those as the baseline, find out from our ag departments, our farmers, from our Department of Environmental Quality, the types of geography, topography we have, and then we can probably make better decisions. But the reason is simple. It's all about the soil.
Yes. Yeah. So what we're referring to here, just so the audience can maybe perceive this a little bit better, is when we drive an electrode into the earth and we perform a test known as a follow potential test, which will establish the resistance to earth of that rod. So when we put that rod in the earth, we're essentially bonding to the earth. And we're treating the earth as a conductor, and we want to be on an equipotential plane, which means no voltage can exist between 2 points. So we drive this rod, we perform this test, we get a value in ohms, and that value is explaining the relationship of the rod to the earth, how conductive or resistive it is. And the soil is going to be so very different in different parts of the world, even in your local geography. So you could have an area that has let's say you drive a temporary rod that's 4 foot in length, 5/8 inch. You could have a resistance value of 100 ohms in one location and possibly 200 ohms, double that resistance in another part of your jurisdiction. And it really gets into the soil constituents. And this is why testing and why the instrument that's in the kit is so very imperative, is that we don't know the soil. We can't really understand the soil without the testing aspect. And that's what we're able to establish using the instrument in the static and grounding and bonding kit. So let's grab, go ahead.
Hey,
yes.
Greg, can I just add one thing to what we're
Please.
talking about here? Because this goes to some of the things Ronnie said, as well as earlier conversations. One of the big audiences, and I'm hoping that there are firefighters, there are emergency response personnel, is a lot of these terms don't necessarily make sense. So if we put some of these in the world of fire speak, i.e. I'm a firefighter, I have no clue what you're talking about with ohms.
Right.
I can also talk to you about something as simple as restrictive. What happens when you bend a hose and you don't have good flow through it? Those are terminologies. The difference between volts, and when we're reading all this, we're dealing with volts and we're dealing with different terms. There are ways that we can turn it into the fire service for you guys to understand it, if that's who's on this call or who's on this webinar. I think you'd find excellent advantage in that.
Yep. So let's take time for just one brief question here. I think we can put do some damage to it to understand it a little bit better, and we'll throw this at Ronnie here. And this gets into that point of redundancy that we discussed. Why do we install individual fields? So why not just drive a single rod into the ground and say, okay, this is my ground system for this site? Why would we need to drive multiple? In the training we teach, it's 2 to 3 depending on the site. So why is it in your perspective we want to install those?
Really about the assurance of grounding, right? If you go with one grounding, you're not going to get a proper grounding, of course, backup to that ground as well. That's the way I foresee that question. And as you've mentioned, typically 2 to 3 grounding scenarios is what we've always used. So probably Glenn can give you a little more technical answer to that, but yeah, that's been our training for the past. Yeah.
My technical response to that, Ronnie, is pretty interesting, and that is, every fire department, every response organization has a guy by the name of Mongo. And what he's going to do is he's going to be walking through the incident scene and all of a sudden trip and pull one of those cables down. And if he does so, that breaks the system. By bonding, by grounding, by have multiple ones, and as Greg said, using redundancy for the system, you tend to ensure that you're not going to have that static discharge at the wrong time. One of the things that we have found, and one of the things that I instruct when I'm doing this, is take some surveyor's tape, put it every 10 feet, the pink stuff or the green stuff or the yellow stuff. Make sure you mark the fields well, make sure they're in very limited traffic areas. But that's the best way to do it. But that redundancy, from my perspective, is still the most important part. Set a ground field for the damage container, set a ground field for the recovery container, send a ground field for your pumping system, bond them together, and you now have a good, safe system that we can deal with and hopefully have that incident mitigated and ended.
Got it. So that really bookends well into discussing what it is that is inside the AEMC static ground and bond system kit, because this should include everything you'll need for your site response for hazmat transfer. Again, I mentioned there's a meter involved, super easy to use to be able to perform the testing on the electrodes. Your electrodes are included as well too. We've got 6 ground rods that are threaded. We've got an extracting hammer installed, so this will also insert and extract the rods for later use. And then we've got a ton of accessories. The big one I want to point out though is the braided stainless steel cables. This is going to be my bonding system for the site. So we're grounding with the ground rods, and then we're bonding everything together and establishing that equipotential plane with a kit that has everything included in it. We shouldn't really require too much more to be able to get the work done of grounding and bonding my site. So Kyle, I think we have tackled this subject pretty well. I really want to thank you for having us on today. Glenn and Ronnie, as always, it's been a pleasure to hear your perspectives, your insights, and your expertise on the subject of hazmat, fluid transfer, and primarily around static ground and bond. So I'm going to pass it back on along to you, Kyle.
Great. Yeah, thank you so much, Greg. Special thank you to our amazing panelists today for your great insights and being so generous with your time. Really was an interesting discussion. On behalf of myself and Marcus Evans, I'd just like to thank you all so much for the collaboration. To turn things back to the audience quickly, a reminder to look out for an email within the next 2 hours with links to view today's material. And if we were not able to address all the questions, we will make sure to send you an email after the broadcast. Finally, would love to hear your feedback about what you thought about today's webinar. A brief survey will pop up on your screen in just a moment. We'd really appreciate any comments that you might have. On behalf of AEMC Instruments and Marcus Evans, we'd just like to thank you all so much for joining us today. We do hope to see you again at future events. Thank you very much, everyone. Have a wonderful day further.